Composite 3D figures, surface area and volume. Calculating surface area and volume of composite 3D figures. Composite just means three figures that have been put together to make one figure. Surface area. Calculate the surface area for each shape. Be sure to exclude any bases that are within the interior of the composite figure. Add the surface area, excluding any interior bases together. For volume, calculate the volume for each shape and just add the volumes together. So these two in red, those are important. Composite means more, they just put together. So be sure to exclude any bases. Exclude means not include, right? They are within the interior of composite figure. And add surface area excluding any interior bases together. So here we have a semicircle here. So we're going to get the surface area of sphere, which is 4 pi r squared. So it's going to be 9 times 2 is 9.2 is the radius. But we're going, since you have a half of it, we're gonna just write half. So half times this is the area of a sphere, which is the top one. So the composite part is the top and the bottom. So we have half of 4 is 2 pi r squared. So 2 times pi times 9.2 squared. 9.2 squared is 84.64. Multiply that by 2 and then hit pi. It's going to give you this. This is the area for the top part. So please write this down. And then the cylinder is 2 pi r squared plus 2 pi r h. So we have 2 pi r h. You have to remember that we got the area for this part already. You see this part, the top base is part of this sphere. So you do not want to include that. That means we just need the area of this, the bottom base, and the lateral area, right? So that is why you don't do 2 pi r squared this is the base area of a circle. So don't do 2 times, just do pi r squared, just one circle plus 2 pi r h, which is the lateral. This is the lateral area. So don't put the 2 from the formula, just one circle, because you already had it from here. So you're going to do, put that into consideration. So you're going to do 9 times 2, 9.2 squared, which is the radius, and then pi plus 2 pi 9.2 times 24, which is the height. And then if you calculate, this 9.2 squared is 84.64 pi plus multiply these two and then multiply that by 2. That's 441.6 pi. You can just add the numbers. That's 526.24. And then if you hit pi, you're going to get this figure. And then you're going to add that top half of sphere and this. And then add them together. You get 2,185.04 square inches. So make sure you do not include that. So don't do 2 pi r squared, just one circle, pi r squared. Okay? So please take notes. Let's take a look at the volume now. It's the same composite figure. You have a half a sphere, called as hemi, and then cylinder. So we're going to do half of the volume, which is 4 over 3 pi r to the third power. This is on your formula sheet. So we're going to do half of that. So half times 4 over 3 is 4 over 6. Pi, just leave that alone. And then 9.3 to the third power, which is this, 778.69 times 4. You have the 4 here, divided by 6. So I times 4 and this, hit pi, divided by 6. I got this figure, 1630.88. That's the volume, plus the volume of the cylinder. Volume, you don't have to worry because it's just inside. So you don't have to worry about overlapping part. So just pi r squared h. Volume, you just add them. And then you're going to do 9.2 squared times 24 and then pi. That's 6381.71. Add these two together. You get 8012.59 cubic inches. So that's the answer for the volume. So the volume, just find the volume, half of this, and then add this volume, and just, that's it. Okay? Only thing you should worry about overlapping is for the surface area, this part. Okay? Alright, so please take notes on that. And then let's look at the composite figure of these two. You have a square pyramid and a cube. So composite means you add those two shapes. So surface area is just outside. So do we need to find this inside here? No, we don't need the area of this inside. Surface area, if I wrap this around outside only, I don't need the area of this part right here. So that's why the pyramid is, if you look at the formula sheet, is half times LP plus B, but I don't need that base area because we're getting the surface area just outside. So we're going to just do half times 13 times 40 because 40 is the perimeter of the square, but we're not going to add this bottom because that's inside. We just need the surface area outside. So that's 260 when you do the math here. And then the cube, you have 10 times 10, right? 10 times 10 is 100. You have 1, 2, 3, 4, 5 on the bottom. But you don't need the top one, right? Because it's inside. We just need surface area outside. So I'm going to do 100 times 5 because there are 5, 1, 2, 3, 4 around and then 1 on the bottom. So that's 500. So 260 plus 500 is 760. So do not count this part because they're inside. For volume, it doesn't matter. You just do the volume for the top, volume for the bottom, and just add. So pyramid is third, base times height. Third, base is 10 by 10, 100. Height is 12, is inside. The height is perpendicular to the base. That's 12. So use that. And then that's 400. Cube is length times width times height, which is 10, 10, 10, 1,000. 400 times 1,000, 1,400 cubic centimeters. So that's the volume. Let's take a look at this composite. So what I need you to do is write the formula for each one and X the ones that you don't need. So here you have a semicircle, which is called hemi. So half times 4 pi r squared. So the r is 6, so it's 36, 72 pi. And then over here, the cylinder, do you need this inside? You don't need that, right? So pi r squared is out. You just need outside surface, right? If I wrap around outside, I don't need the area of this circle. So X that out because 2 pi r squared is the area of the circle. So we don't need this area or this area. So we're going to take those out. Just do 2 pi r h. So 2 pi r is 6. 12 is the height. That's 144 pi. And the cone, we don't need this part, right? The circle we don't need. Just need outside. So 2 pi r squared is a circle. X that. Just do pi r l, which is pi. 6 is the radius. 10 is the slant height, which is L. That's 60 pi. So you do 72 plus 144 plus 60, which is 276 pi. And just hit pi once, and you get 867.08 square unit. U means unit, okay? So you want to write down the formula, X the ones that you don't need. If it's inside, you don't need them, okay? Just the outside surface. That's surface area for you. So try this problem and then put it in the Edpuzzle. For volume, you just find the volume for each shape and just add them up. Do not worry about inside. Now we're going to look at congruent and similar solids. So congruent solid, two solids of the same type with all equal linear measures such as heights or radii are called congruent solids. So when they have all equal measures, they're a congruent solid. Here are similar solids, two solids of the same type with equal ratios of all corresponding linear measures such as heights or radii are called similar solids. So right here, the ratio of corresponding linear dimensions of two similar solids is called scale factor. So take a look at these cubes. Any two cubes are always similar as they are any two spheres. So here you have, this one is similar to that. This one is similar to that because they're gonna have they're gonna have scale factor. So here, identifying similar solids, we generally compare solids from left to right unless we are told otherwise. So you just must check the ratio between all corresponding sides. In order to be similar, all ratio must be the same. So here you have two shapes here. Are they similar? If yes, what is the scale factor? So you're going to do 12 over 8. So go left to right. And then 3 over 2. So that is 12 times 2 is 24. 3 times 3 is 8 times 3 is 24. They have same ratio when you cross multiply. So that one works. And then you look at 6 over 4. That's reduced to be 3 over 2. So when you reduce each fraction, you get 3 over 2. So everything, the corresponding, they all have to have same scale factor of 3 to 2. Then these two 3D figures are similar figures. So they must have same scale factor. So just go left to right, each corresponding side, and make sure they have same thing. So take a look at these two cones. Are these similar? If yes, what is the scale factor? So you do 18 over 6, 8 over 4. 18 over 6 is 3 to 1 ratio. 8 to 4 is 2 to 1 ratio. Not similar. This is a similar symbol. Take a look at this one. 6 over 5, 12 over 10. So 12 over 10 is 6 over 5. When you reduce, they are same scale factor. Then these two are similar. So similar means same shape, different sizes. Same shape, different sizes. But they must have scale factor. Even though they look similar, doesn't mean it's similar. You need to have same scale factor. Okay? Same proportion. So similar solids and special ratio. If the scale factor of two similar solids is A to B, then the ratio of their corresponding area is A squared equal to B squared. So when you do area, you do square units. And this ratio works for area of base, letter area, and surface area. Ratio of their corresponding volume is A to the third power, B to the third power, A cube, B cube. Because this volume is cubic units. So square units for area, cubic units for volume. The ratio for perimeter is A to B. Okay, just regular. So take a look at here. I have A to B, which is the scale factor of two similar figures. If you want to compare their areas, it's A squared, B squared. Volume, A to the third, B to the third. So let's say if it's 1 to 3, it'll be 1 to 9, because 1 square is 1, 3 square is 9. And then volume will be 1 to 27. 1 to the third power is 1. 3 to the third power is 1. Same thing for 7 and 4. Just square it, cube. 6 and 11, square for the area, cube for the volume. So let's take a look at this. So you have an area ratio. So A squared to B squared. Write that down. Surface area, surface area. They gave you area is 18 to 32. So we're going to find the regular scale factor, which means we're going to do square root of each one. We don't just reduce this. We square root of each one because that's going to give us A and B. Because opposite of square root, square root. So if you do that, you get 3 radical 2, 4 radical 2. Cancel like terms. 3 to 4 ratio is the regular scale factor for this one, for the size. If you do volume, you're going to write A to the third, A to the third. Because this is a cubic root, so that's why you write that. And write 216 over 343. Do cube root of each one and put it in the calculator and divide. You get 6 to 7 scale factor. So let's take a look at these two similar figures. The scale factor is 9 to 6, so that's 3 to 2. What is the volume ratio? Volume, you're going to write A to the third, B to the third. So 3 squared to 2 squared is 27 to 8. If I want to write the proportion to solve the other volume, 27 to 8 equals 1215, which is the volume that is calculated over X. So we're going to do big over small, cross, multiply, and divide. You get 360 cubic unit, because we don't have measurement here. We just write cubic unit. Go ahead and do the next one. You have the measurement here. I want you to write the scale factor and write the ratio and then solve for the smaller one. Try it.